Hi everyone. So I've been asked to do a recap on the pumps and especially these calculations that go with the pumps. So I'll put this in the description as well. But with the notes regarding pumps, there's a certain section on page 12 that looks like this, and it says the following. It gives you this line that says centrifugal pumps are usually identified by what is known as a pump code. The pump code generally assumes the following form. So you've got your pump code, then you've got that AAA, which is the make, triple B, which is the pump series, the nominal diameter of outlet in millimeters, and then lastly that triple Y is the nominal diameter of the impeller in millimeters or sometimes in centimeters. And so at the back of any paper you get a graph that looks like this. So on this graph there's a lot of values, a lot of things are said, but I'm just going to highlight what's important on this graph. So if you are asked what is the pump speed in revs per minute, so you can see this square at the bottom, and it says U per minute RPM. That is the pump speed in revs per minute. And so if you look at these values, you'll get a bar here on the right hand side. This one says Etanorm, so that is the make. The pump series is that ETA, so that is the pump series. The nominal diameter of the outlet is 50, and so the nominal diameter of the impeller is 250. So that's the make. That ETA is the pump series, the diameter of the outlet is 50, and the nominal diameter of the impeller is 250. Okay, so it says that or let's for argument's sake say that we have a pump that pumps 30 cubic meters of water with a 220 millimeter impeller. So what that means is you'll take this graph and you'll say, okay, so the 300 cubic meters per hour that the pump is pumping is going to be this line upwards. So this vertical y-axis is at 30. So maybe if I hold it closer, you'll see that there is 30. And so everything upwards in the vertical y-axis is 30. And then it says the impeller is 220. So millimeters. So here you've got 220, 230, 40, 50, and 259. So that is the values that you will need. So the only two values that you'll be given is the flow rate of the water, which is this Q. So you'll find it on this axis and then you just move up. So in this scenario, in this example, it's 30. And then the impeller diameter, which is 220. And as you can see, that 30, so if you move up, and that 220, they cross each other right at that point. Okay, so that 220 and the 30 cross each other right there. So a couple things that you need to know is that if I ask you to give me the cutoff pressure, or the cutoff distance, sorry, in Afrikaans, the afsluitpunt, you'll take that 30 and 220 and you follow this curve right back to there. So in this case, the cutoff pressure, the cutoff distance, on Afrikaans, the afsluitpunt is that point right there where the line crosses the y-axis. So the next one is pump head at duty point, or pompdruk by dienspunt, and it is that point where this flow rate and the impeller where they cross. So that is the pump head at duty point. So just not to get confused, this is the cutoff distance and this is the pump head at duty point. Afrikaans afsluitstand or pompdruk by dienspunt. So that is the two important ones. So next it can ask you, what is the efficiency of the pump at duty point? So you know that this is the duty point. This is DP, dienspunt in Afrikaans. So this is the duty point, this point where this line and this curve, they cross. So now I'm asking, what is the efficiency? And so these lines that curve down all the way here, all these curves, they are the efficiency. So if the efficiency, if the duty point is here, the efficiency will be this value, this 60. That is going to be the efficiency of the pump at duty point. Maybe if the duty point was over there, then the efficiency would be that 65. Or if the duty point was maybe over here, then the efficiency would be 50%. So if you've calculated cutoff distance, which is the y-axis, and then the x-axis, which is flow rate, if you've calculated cutoff, you know what the pump head at duty point is, which is over there, and you've calculated efficiency, then you've calculated everything on this part of the graph. Next is going to be this one in the middle. So that NPSH stands for net positive suction head at duty point. And so because you are still at that 30 cubic meters per hour, you are cutting this graph right over there. And so you know that the net positive suction head, where this line cuts that curve, is going to be 2 meters. If, for instance, you had 60 cubic meters per hour, then you would be on this line, and your net positive suction head would be 6. So if you take 60, if it was that, and you were there, then you'd walk back and find 6. And so the last important thing I maybe could ask you is the power consumption at duty point. So you are still at 30, you are still at 220, so that's that line. Now you want to calculate what is the power consumption, and so it'll be that line, and you work that right back to there, and it seems like it cuts at 8, between 8 and 9, let's say 9 maybe. So maybe just say 9 kilowatts. And that is all you need to know for pumps and calculation of pumps.